You're unable to see my screen, right? Okay. So today we'll cover one very important topic. Kind of, it is very important in the interview perspective as well as while you are working on real-time project, you'll encounter this quite very often. We'll see about exceptions, all right? Create new package for that. Even in kind of Selenium, whenever there are few exceptions in Selenium, if people might have known, there is something called element not found exception, scale element exception. Every time you cannot expect some element in your screen to appear based on already presented website or something like. It may change due to bugs or a variety of reasons. To handle those kind of scenarios, exceptions are very important in any programming language. Just create a class. Create a main function. So can anyone say me, like, based on your understanding, what is a exception? Any simple scenario where exception might occur in our program? Can anyone say?
NullPointer exception.
Yes, null pointer exception is very frequent, right? And most common exception is null pointer exception actually, and it's kind of very irritating when you wanted to do some logics over any object in Java. For any object, you have to check for null pointer exception basically if you want to cover those edge cases. Uh, except the primitive data types. For example, primitive data types that cannot hold null value, right? If I try to assign null here, it will throw an error. It cannot handle null value. Even if you change this to an integer, to do a proper coding and all, you have to check for null. That's the only very big mistake where people have developed this null kind of conceptual early program. That is an interesting story about how this null came into programming. Well, maybe I'll post that once I get some links. It's a very interesting story actually. But let's start with the basic. We all know, right, the output of this. So let's try to run this program. It's basically a divisive operator, right? So you have this 8 and you have this number 2, and a by b it gives 4. Even I have some numbers which is not divisible properly. It is going to return the quotient, right? It will not return the remainder unless you have some float values and all. So what happens if I replace this b value with 0, right? Anything divided by 0 is infinite, right? Infinity, right? So it is not going to handle that scenario, or our program will not throw some exception saying like the answer is infinity, or the program will not give some value as infinity. Let's try to run this program. So it is throwing an exception, right? Let's open the console. So it's throwing an exception. Say this exception has occurred. This some exception called arithmetic exception or divide by zero exception. Like, so whenever you encounter some exceptions with numbers, uh, you generally encounter this arithmetic exception. Exception in the numbers, what I mean is like you do some operations over those numbers, like addition, division, multiplications, and all. So you encounter this particular exception called arithmetic exception, which is already inbuilt into Java. Okay? But if you notice one thing, this thing is not handled at the compile time. Right? We only get to know at the runtime. Why the architecture is like that? Because we have hard coded the value 0 here, but in the real time, we may get data from the external system. We may iterate over a particular series of arrays, or iterate through a database and get the numbers and try to perform an operation like this. In that case, we will not know what is the number there. Right? Every time in the compile time, we cannot go and check the number which is dividing, right? So we cannot do that in a compile time. This number we have hard coded here, but this number can come from anywhere. So are you getting the point, right? So you can post your responses in chat. So you cannot do these things in the compile time itself. So we call this as unchecked exception. These kind of exceptions as unchecked, right? So generally, how we will handle the exception here? What exceptions we are getting? We are getting an arithmetic exception, right? So generally, how we will handle the exception? Everyone knows, right? Using try catch block. I have my try here with open close braces. I'll have my catch block immediately with brackets saying like what exceptions I need to catch. Here, what exception I am intending to catch? I'm intending to catch arithmetic exception, right? So I can do something like this. Arithmetic exception. I can create an object for that. Let's do one thing. Let's print the message like this. And if you go to that object A, you can see series of messages right like this. We'll try to get the message here. You can see there is an option called get message here, which is of type throwable. We'll come to this exception hierarchy in a while. So I'll just try to get this message and we'll try to put this particular block inside this try. Okay. Oh, sorry. It's saying duplicate variable because I already used here. Right? Okay. So this is a basic syntax of a try catch block. You have try block here. Try block is something where you will put all the codes or the logics of your program. Catch block is something you catch the exception. You wanted to do whatever you wanted to do with the exception. Right? You want to try out whatever you want to do with the exception. That is the catch block. Right? You can try to run this program. Okay. Now it is printing our custom exception. I mean custom message, right? Now we all know like okay, this line is executed. and whenever this line is executed, exception occurs. Now it is not throwing some ugly stack trace like we saw in the previous example, right? Now what happens, we explicitly caught that exception, and we are handling it out. We are just printing, we caught some arithmetic exception, and we are getting the message. Now the message itself says it's a divided by 0 exception, right? So these are the advantages of what you can do with those things. One big caveat is like you cannot, after catching the exception, you cannot continue the program. Exception will be caught and the program will be terminated. Like it will not go. What I mean by is like it will not go to the try block again and execute remaining statements. For example, if I have some remaining statement, something like this, int c is equal to a plus b. So if I have something like this, it will not execute. So it's not a coming to printing this C and all. So exception is caught and the program is terminated. There are only workarounds in Java where you can go and execute this again and again, like implementing some while loop until a condition is satisfied. Some loops implementation, maybe we'll see that later. But generally, once the exception is caught, it will not return to the try block. But in some programming languages like Ruby, you can do that. That is the only caveat here. This is thing which I wanted you to know. Right, so far so clear, right?
Yes.
Okay. So what we'll do, I can also do something like this. I can print the stack trace like this. So now stack trace is printed. So what is the advantage of this stack trace is like, for example, we caught the exception. Okay, okay. We caught the exception. Imagine that you have some very huge project which we saw previously, right? Something like this. Very huge project where you have so many modules, and you want to check these exceptions and all. You cannot just catch every exception and you can handle the customer logic. It will kind of lead to problematic errors, because there's one very big advantage of this exception trace. Actually, you can see at what class this exception is occurring and in what line, right? We print a stack trace. So that is kind of very useful, right? It is now it's saying exceptions testing class and in line number 14. Right? So this is exception testing class. Exactly line number 14, exception has occurred. So exception has occurred here when we are trying to divide a by b. So now it's very easy for us to debug. I'll change the value as 1 here. Now I'll know. Now I'll know, right? What is the error? Now it's printing, right? 7. We are printing this here because we are adding it and printing C. So now we'll know where that exception occurs, and we will be able to solve that problem actually, right? So printing this stack trace also is very important. Usually, there are some logging frameworks. We will not do some console logging in real-time projects. Maybe in a kind of very big projects, right? There is something called loggers. For example, we don't use system.out.println in our real-time projects, right? And also we don't use stack trace like this. Uh, Maybe if I wanted to show, okay, there's some one framework called log4j, right, in Java. Maybe you can explore that by yourself. There are small examples I'll try to show. Okay. These are the important logging levels in every logger framework. You put log.debug to print some message where you have to debug something by printing some variables at the runtime. Log.info just for information level, like okay, something is happening here. I'm just informing in the console something is happening here. Log.warn is like a warning kind of level. Okay, you have detected something. It has to be corrected in the future. Otherwise, it might lead a problem. Log.error is like it is generally used in a catch block. Definitely some exception will occur. You have to print the error like that. So log.title is there, log.trace is there. So these are the important things which you have to note. See, we'll do something like this, right? Generally, logging frameworks like this is used, but understand that logging framework is also, it's going to print your stack trace, but in a different kind of format, right? Or in a different way, you can say, not format, in a different way. So generally, for a testing purpose, if you do something like this, printing a stack trace, it's more than enough. Now we'll try to run this again. We'll try to. So once you do that, only you'll come to know like in what class and what line number this exception is occurring. So that is a very important thing. Now we'll do one more thing. Instead of this arithmetic exception, let's try to do this itself, exception class itself. Right? We'll try to run this program. Again, we are getting the same output, right? There is something called exception hierarchy, which I will show you. The basic thing which I wanted to understand is like, for example, let us go to this arithmetic exception class actually. So it is extending something called runtime exception. Right? If you go to this runtime exception, it extends exception. Right? So every runtime exception will extend exception. These are runtime exceptions we saw previously. It cannot be detected at the compile time. So these are kind of runtime exceptions. So I can either use the arithmetic exception itself, which I know, or there are cases where I don't know what kind of exception I'm going to catch, right? In those kind of scenarios, you can use this exception. The exception is a very generic class where most of the exception classes inbuilt in Java will be extending that. See, in many cases, people will not know what kind of exception that they are going to catch. So in those kind of scenarios, most of the people will probably use this exception class itself. So we'll know for sure whatever exception it may be, that exception will be closed and caught and the stack trace will be printed like this. You can do something like this also. Let's put arithmetic exception here. So I can have a multiple catch blocks in my program, right?
Karthik, that line number 24 get message is an inbuilt method.
Yes, it's an inbuilt method to get a like inbuilt message where the program is built upon. It's from the throwable class. It's if you go here, yes, it's from the throwable class, right? So it will return the message of what the exception has occurred. In this scenario, we are getting the divided by zero, right? This divided by zero message is got by this get message only. So it is kind of inbuilt inside the Java itself, this get message.
Yeah, okay.
Okay. Okay. Any other person has any other question until what we saw?
I have a different question here. Like, I will get to
Okay.
know how to use that execution logger to track
Execution.
all the. Yeah.
Okay. I didn't get your question properly.
Actually, not execution logger. Basically, when I'm running Selenium scripts.
Okay.
So everything I need to log into a log file.
Yes, right.
So I need to know how to do this. My question is not relevant to this context as of now.
Okay. Maybe we'll come to the Selenium framework building part, right? We'll see that. So as I said, you will implement this kind of logging framework. The Log4j is very popular framework. As I showed you previously, you can integrate very easily with your Maven. Anything, I mean, if you're creating some test automation frameworks, obviously you will use some build tools, right? Like Maven and Gradle.
Yes.
Yeah, you can easily integrate this log there. And once you integrate that in your output folder, wherever you are configured, there is something called log folder that will be automatically created.
Okay.
With some extensions .log. Okay. So once that folder is created, every log that you are printing here, right, as we saw previously. So whatever you are in your program, you can use this log.1, log.trace. Wherever you want to, wherever you are doing this, all the logs will be captured in the log file. Right? So either you can see those log files to see what is the problem. You can use your VA editor and search there and see what is the problem. Or what you can do, if a test automation suite is running, everything will be printed in the console, right? So getting what I'm trying to say, either it will be, if you're running through a IDE like this, it will be printed in the console like this, which we saw here. It will be printed in the console like this. This is a console, right? Or if you're running through any command line terminal, then it will be printed in the terminal here, right? So
Yes.
in the real time itself, you can see what are the message that is logged in the terminal itself.
Yes, right.
Those are the things that we can do.
But yes, actually, I mean, this is also a helpful thing. But the problem was, like, suppose if I am facing multiple errors in multiple functions, accidentally, if I rerun the test again, all the previous console logs gets deleted, removed.
Yeah,
it
console
starts.
logs will be deleted, but it will be present in the logging for logs folder, right? So only it is
Yes.
beneficial to use the log4j kind of framework.
Right.
That is one of the use case we are using that, and log4j kind of frameworks will also give more power to you. Like there are multiple levels where you can log like this, and there are additional capabilities also. Maybe we'll try to explore this in detail. And there is one more famous logging framework called SLF4j. This is also very famous actually. Maybe we'll see that in later classes. But log4j also gives you the additional functionality where you can customize your logging output in different formats, and you can store that as a log file also. So that's a very big advantage of using those things. So console you should not depend every time. Obviously, it will fade off once you. There is something called console limit. I think you know, right? For example, I can say I set this console limit to some 10,000 lines, either in our terminal or wherever console you wanted to run. If it's some remote server or in your local machine, if I set some 10,000 lines, even though I'm running the thing again, see some exception has printed here. Right? I think I have ran some automation script only here. So it's printing some error, right? Even though if I'm going to run this program again, I mean run this test automation again, still this stack text will be there until the number of lines in the console printing have crossed. So once that is crossed, it will be vanished.
Okay. Yeah.
Okay. Even you can see in this example also, what's the use of printing those logs is like, it will show the class hierarchy where the exceptions has occurred. First, where the exception has occurred is like in this particular class at line number 802, which is called by this method, and which again in turn called by this method, which again in turn called by this native method. So you'll get this in-depth detail hierarchy, right, from the basic Java level inbuilt methods until the methods which you have created where the exception has occurred. So it kind of gives you very detailed analysis and things for you to debug. So class method can be called by multiple methods inside the multiple classes, right? There is one method called ez. I can call from a method called in the class called y, and again in turn it's a call from class called z, x, something like that. It will go on and on in a very big project. It will be very difficult to debug in that case. If there is some logs like this, it's very useful. One more very useful feature of id is like there's something called hierarchy, call hierarchy. Is anyone aware of what's a call hierarchy? It's a kind of very useful for very big projects. Maybe I'll show some example. I have this normalized string method here, right? It's kind of a very big project where I don't know who calls this method at all, right? So how I can go and check is like it is the IntelliJ IDE. We have some shortcut to open this call hierarchy. Eclipse, we have some other thing. So what happens here is like if you open this particular method, see it's called by this class, right? Page visit query, which is in turn called by this get bool query method inside this ESGenerate query class, which is again in turn called by this particular method. And if you open this particular method is called at the three places here, right? One in the ES contact fetcher class from the method get segment count at count for method, which is again in turn called by these four methods, right? You can go on and on like this until you have reached the end. See how many methods are calling this. It's similar to seeing an call hierarchy without an exception actually happening in the runtime. So if some actual problem occurs in your program while you're debugging compile time or runtime, if you use this call hierarchy, now I'll know what are methods are calling this particular normalized URL string method, right? This particular thing is called by these many methods, which again in turn is called by these many methods inside, right? It's kind of very useful tool. So it's one of the biggest advantages when you are using IDE. Try to explore this. Is kind of very useful actually, right? For example, let's say I have this get bool query. If I go here, yes, in that particular line it is called, see this method here, right? This get bool query method is there in the class ES query generator. In that particular thing, it is called at the line number 159, which is called, this one is called generate page visit event query. This method is called here, right? If I go to this method, again, we are in this level and we are calling normalized string, right? Normalized string is called where in this method in the line number 324, right? Now, once that is called, it will come here. Normalized string method control will return to here. So this is how you debug in very large projects. Fine. You can do something similar with Eclipse also. If you double click on the method and say open call hierarchy, it will open the call hierarchy. Now this main method is not called anywhere. This is the main method, of course. So it is called in only one place. Otherwise, the same kind of hierarchical pattern where you see is on the IntelliJ, it will be kind of repeated here.
Karthik, I have a question here,
Okay.
but this is also not relevant to this context.
Okay.
Well, actually, if I have a Java project which is working in Eclipse,
Okay.
can I import the same Java project in IntelliJ IDEA in the
Yes, why not? Why not? You can do it very easily. Generally, like what kind of projects do you have? It's kind of a any Maven project only, right?
Yes, Maven and test engine.
Yeah. Then it's very easy only. Wait.
Well, actually, I was suspecting like we sources main Java, sources test Java. Those type of folder structure will support in IntelliJ
No,
IDEA.
no, yeah, it will support. If you open project, right? If you open project and when you go to the project folder,
Yeah.
Um,
The parent folder, the main folder which
yes,
under which the POM XML exists.
Yes, yeah. So if you open that Maven project itself, our IntelliJ will itself detect, it will check for whether Maven pom.xml file to check whether it's a Maven project, because this Maven is inbuilt here. I'll show you it. Maybe I'll show you. This Maven kind of things are inbuilt actually here. So you can see Maven here, right? So Maven framework is inbuilt into Eclipse and IntelliJ as well. So once you go to that main folder, top folder where the pom.xml is there, you can IntelliJ itself will know, okay, it's a Maven folder. It will ask you to, there will be some checkbox coming whether it will ask you to import as a Maven or regular Java project. You have to select obviously Maven project and give import. That SRC main Java, SRC test Java folder structure is kind of folder structure which belongs to Maven arch type, right? So that folder structure is generated because you have selected a Maven project. Are you getting my point? So our IntelliJ will defaultly know, okay, this is a Maven project, this is a folder structure, then it will create something like this, right? See here I have a SRC test Java, right? Here I don't have SRC main in our project. Here I have SRC test Java. So our Maven kind of knows, okay, this is a kind of a Maven project. We have pom.xml here. So I have to import, I have to check for in the folder structure here. I don't have SRC main Java. I have SRC test Java. So it said me, right? It's asset test Java. And for any project, the target folder will be created. This Maven kind of arch type target will be generated for the outputs and classes. So it is also knowing, it is marking this as in orange color if you see, right? So our IntelliJ defaultly notes, okay, hey, this is a target folder for Maven. So I have to mark this as a separately like that. So it kind of knows actually.
Correct.
Fine, Sagar.
Yeah, thank you.
There should not be any problem doing this. One more thing, if you go to IntelliJ, you have lots of plugins there. I think you have plugin for you will have plugin for TestNG also.
Yeah, actually, I need to do it from my end also, and only after that I'll get to know if I face any challenges.
Okay.
So if I have any challenges, then I'll definitely get back to you.
Okay. Fine. So we'll continue this.
Yeah.
Okay. So what I was saying is like we can, for one try block, we can have multiple catch blocks. That's the point. For example, I'm going to catch one more. I'm going to catch the exception itself. Right. This is main exception catch block. But if I try to run this now, again, this particular block of code is not run, right? Because there is something called exception hierarchy. Okay, probably I'll show that now. This is called exception hierarchy in Java. Every object will extend this object class by default. We know that. For exception hierarchy, there is one base class called throwable. I hope you people able to see this.
Yes, we can see.
No, we can see. You can see it. Okay, there is one class called throwable. Which from the throwable only all the exceptions class will be kind of inheritance concept, right? And you have error kind of things which is inherited from the throwable. What is an error? We saw the previous example, right? In the recursion example, I think we saw there is one example called stack overflow error, memory out of error, right? We saw it while running the while loop infinitely. We saw some error while doing the recursion continuously for many times. We saw some error. So these are the errors which kind of not recoverable at all. Once that error occurs, you cannot do anything about that. Again, you have to restart your server or clear that memory area by yourself. Until that, the program will not be executed. So error handling is kind of tricky in any programming language, not necessarily in Java. So we have to be very careful while doing a recursion or while doing a while loop, for loop. That to be very careful with the base condition. When to terminate that loop condition is very important. Otherwise, it will lead to out of memory error, right? And in the recursion to lead to stack overflow error. These kind of errors is coming from this error hierarchy class, right? Maybe I'll show one thing. So you have the stack overflow error, right? Which extends this. When the stack overflow error comes, it comes when we are trying to do the recursion infinitely above the memory heap size of any programming language, which extends this virtual machine error, and in turn this extends the error, right? Error class, right? And what it is extending, error class is in turn extending this throwable, right? This is the same hierarchy which we saw here. We have this stack overflow error, we have this virtual machine error from which it is extending, we have this error from which this is extending, and everything is extending from this throwable. This is the hierarchy in Java for error. So a similar way, we have this exception hierarchy. Even this exceptions class is coming from this throwable class only. So show these exceptions. So this exception class also extends this throwable. Throwable is kind of a master class for everything, every problem you have in your Java. And this exceptions class is broadly classified into checked exceptions and unchecked exceptions. We'll come to checked exceptions in a while, but whatever we are seeing is unchecked exceptions only. All right, runtime exceptions which cannot be caught at the compile time. So this is the exception hierarchy. So this, you can see exception comes at the top, and whatever this arithmetic exception we got, it is extending that exception, right? For example, I'm having this arithmetic exception class, which is extending the runtime exception, which in turn extends this exception. So exception is kind of a top level class for the arithmetic exception, right? So in our program, the top level catch should be always at the bottom. You have to start from the minimal level, right? I mean, it's optional. It's up to you to decide whether you want to go by this approach or not. But generally, if you do something like this, it's kind of more error free, right? If you have only single catch block with this exception, you can obviously use that exception will be caught. But if you do fine tune something like this, okay, I'm going to specifically catch arithmetic exception only here, then no other exception will be caught here, right? Obviously we have this catch block, another catch block here, and here, for example, let's assume this catch block is not there. So if you have this arithmetic exception, only arithmetic exception will be caught. Null pointer exception will not be caught, right? So that's advantage. You can fine tune that. You can do whatever you want with that block, right? Let's try to do some alterations here. What if I have something like this? It's already throwing me an error, and something like this, right? It throws me an error, right? Unreachable code, right? Why it's unreachable code? Because we have already got to the master exception. Arithmetic exception is kind of a subclass to this exception, right? We have already got the master here, so it will not go to this particular piece of block itself, right? Getting the point? Whatever we got exception here itself, it will never reach this code at all. So only it's showing the error code not reachable. So you should not do like, you cannot violate that exception hierarchy while using the multiple catch blocks. That's a thing here. So getting the point, right, everyone?
Yes.
Okay. So you can do only something like this. You have to catch this arithmetic exception first, or maybe exception itself first, and then you have to process in a sequential manner. So that's the whole idea. So I can go on and on. I can have one more catch block before this exception block and have some null pointer exception caught. I can do like that also. So what we'll do, we'll try to see one more thing here. I can have a try block inside a try block itself. It's kind of a nested try block. Right? So I have a try here. I can have one more try here also. Let's say okay. Let's wait to do something here. Another very common example is null pointer exception. We already saw, right? Let's try to do this. Let's try to declare a string variable here. String br is equal to, let's say selenium. Okay. Let's try to do a sysout. What I'll do var dot let's do this index at 0. So we are printing the first index of this particular element. Obviously, it will print yes only. We are catching that. We'll try to print this nested exception block. So we'll do this. We'll try to run this program again. This code will be not reachable to this try block at all. Yes. Okay, because exception is caught at the 14th line itself, it will not go inside this try block at all. Let's do this. Let's put this as 1. We'll try to run this now. So now this yes is printed here, right? So this particular try block is executed. Now no exception is caught because we have something at character index 0. This yes is printed right here. So try block within try block also works. I can have this exception hierarchy worked here also. What what happens if I declare this variable as null? Right, it's throwing me a warning. Null pointer it's already throwing me a warning, right? Let's try to run this. Yes, exception has occurred, right? So what it says two messages. We have printed this message. We have printed the what exception that has occurred by calling that get message block. So now it has entered. Now we know for sure this is a null pointer exception, right? Null. So this null pointer exception is kind of very common exception that we'll encounter in real-time project. Whenever you try to access something of null variable, right, it will lead to null pointer exception. Any kind of thing which we try to access a method of an object which is a null, or which we are trying to do something action with a null, it will throw a null pointer exception. You are trying to access something, doing something using a null, right? So it can be caught specifically through a exception called null pointer exception itself. It will catch that. Again, the same output here, right? So only like if you go for any programming interviews, very in any good companies, if they ask you to solve some programming code, right, some coding problems and all, they will specifically see whether if you are solving this null and empty case. So if the input is null, then what is the expected condition. If the input is empty, what's expected condition? These are very basic edge cases which every interview will ask you to see if you are able to identify and solve, especially in good product based companies, right? Or the main logic everyone will write, but everyone will miss in this particular thing only. For example, uh, I can put a null check here, right? This is very, very important. Then I can probably cut this and put it here. Okay, it's saying dead code because it's already null. Let's say it's I'll put something like this. So we will never know, right? This variable comes can come from anywhere, right? It can come from again an external system database as a JSON. JSON can also have null values for information. So if we have some check like this, then it is always, we are always sure that we are going to do some action only if the variable is not null, right? So these kind of checks are very, very important when you are doing actual programming. Then we'll know for sure, okay, hey, our program is not null like that. Right? Now we know for sure, then that is printed.
Karthik, where are 7 and 8 coming from?
Okay, 7 and 8 are coming from here. We are printing a by b and we are printing a plus b here. We'll
Okay,
try to
got
comment this
it.
program. Right. Now fine.
Yeah.
Okay. So this is the main thing which you have to handle every time, so that this kind of null pointer exceptions are avoided. In most of the times, whatever I have saw in my real life, this null pointer exception has caused many big problems. We are working on some product called a Fresh Marketer. It's a kind of a cloud-based online app. Right? What happens if I even sign up failed? Basic sign up use case itself failed because the null pointer exception has occurred in validating some address. Even yesterday, that problem happened for us. Null pointer exception are very annoying actually. So that is one thing which I wanted to show. Maybe we'll try to create another class to do another things. So there are other kind of exceptions which are also very common. For example, I'll show one small example of what is a checked exception actually. Checked exceptions are something which you are going to do at the compile time itself. In many Selenium projects, you will commonly encounter this. Right? There are wait statements inbuilt to the Selenium itself, like explicit wait, implicit wait. But there might be many conditions where you will have to do this thread.sleep explicitly. For example, in my real-time project itself, I have one scenario like where I have to send email and wait for the email to receive from in my mailbox, go to the mailbox, check if the email is received. So email is something which is out of our regular web-based testing, right? So I cannot wait for email to load as I wait for some element to load in my project. So what I have to do? I have to do some thread.sleep for 60 seconds, something like that. I have to put something like this, 6000 mils, 60 seconds. Then I have to do something like this. So once you do this, you are getting some error here, right? Unhandled exception, interrupted exception. So interrupted exception is something is a compile time exception. Why it's a compile time exception? I'll show shortly. So what it is asking to either throw that particular exception or asking to surround with try catch. So either I can do either one of that. So what here I'm trying to do, I'm catching interrupted exception here. I'm printing the stack trace, or what I can do, I can directly throw that exception in the method declaration line itself, right? Either one is possible. So why it's a checked exception is like in the method creation part itself, we have thrown this exception, right? This will definitely throw this exception. We have said in the Java class itself. So now for sure we have to handle the exception compulsorily here. So otherwise it will throw a compile time error itself, right? So only it's called a compile time exception because we have explicitly stated that this particular sleep method will throw this interrupted exception. Right? Otherwise, if you remove this interrupted exception, it will throw an error. Same error which we saw. Unhandled exceptions, right? So these are examples of compile time exception handling. What this thread.sleep will do, it will put the thread to hold for 60 seconds. Every Java program is executed in thread, right? Thread is a kind of a worker which goes and executes your program inside your CPU core, CPU processor, right? If a thread itself is put to hold for 60 seconds, a thread will have those instructions which are in that particular thread that have to be run. But every instruction will be kept hold for that much number of duration. Right? That is use of thread to sleep. Generally, thread.sleep should be avoided, but in specific case, we don't have any other option to do. Thread.sleep is kind of very frequently used in our automation projects also, right? So everyone got this point. It's kind of one type of checked exception, right? Let's not wait for 60 seconds. Let's wait for some 2-3 seconds. What I will do, I'll create something like this. Let's try to run this program. If I run this program, what will happen? Can anyone say? Let's do this. Can anyone say what will happen?
It will be array index out of bound exception.
Yes. It is array index out of bound exception. Right. This is also one very frequent exception which we will encounter when we are working with arrays. Right. It's kind of very annoying, very frequent. For example, you are iterating an array which is out of bound, right? Why this fourth index is kind of out of bound? We have only 4 indexes, but indexes start from 0, right? So 0, 1, 2, 3 is allowed. Only up to 3 is allowed. So now, okay, again we are trying to access this fourth. So it's printing here, right? It's printing 5. So what happens here is like we are whenever you try to access certain index location of an array which we have not specifically declared or initiated, then it will throws array index out of bound exception. Again, we can explicitly catch that exception here. And if I limit it to 3, it will throw some exception for me, right? So it says array limit exceeded. We have caught the exception. It says array limit. Message is what? it just gives 3, right? So it means that at the index 3rd we are getting this array out of bound exception. So we'll try to print this tag trace also. Execution delayed because we are asking this particular thread to sleep for 3 seconds, right? So only it's kind of delayed. So it's throwing the exception here, right? So it says index out of bound at the index 3, and exception is caught at the class exceptions at Java line number 12. Right? So at this particular line, we caught the exception. And one more before signing off, one more thing which I wanted to show is this is also very frequent exception actually. Let's say you have some string here. String A is equal to, let's say 1, 2, 3. So if I wanted to convert this string to an integer, what I will do? Say integer I is equal to a dot, sorry, integer dot parse int. I can use some parse int method which is available in integer class. I can pass this a here. Okay, this object here, right? Now if I try to print this, it will print this as an integer, not as a string, right? We'll try to put this as 4 itself for time being. I'll try to run this program. Maybe we'll remove this or put this as 1 second delay. Try to run this. It's printing 1, 2, 3, right? So now there are many scenarios where you wanted to convert a string to an integer in Java. And you generally use this parse int method. What if string may contain numbers and may not contain numbers also? Generally, you check that if string contains numbers or not using something called regular expressions. We'll see regex in later point of later video, maybe later sessions. But what's the point is like, let's try to run this program. I have some a here. Again, throw an exception, right? What exception is throwing? It's throwing number format exception. This is also very frequent exception which you will get when you're doing something like this, parsing a string which doesn't contain total numbers. So I can add one more catch block here. Exception is number format exception. Let us try to run this now. Now we are catching the number format exception, right? Now we see the what message is saying. This number format exception occurred because of the input string 1, 2, 3 a. So now we know for sure because of the string only the exception has occurred. Now we have two catch blocks with two different exceptions, right? This is also possible. So if the array out of bound exception occurs, then this catch block will work. If number format exception occurs, this catch block will work. So we can make our program to work in this way also. Right, everyone? Hello?
Yes, I'm okay.
Okay, what about others? No one is saying anything. Varsha, Vinay, Anchal, Mithun. Okay. Okay. We'll wrap this session today until now. There are many more topics to cover in this exception. I hope like what are basic exceptions we saw, it's kind of clear. We saw this number format exception, null pointer exception, array out of bound exceptions, and this arithmetic exception, right? So just try to work these out. These are very, very simple scenarios where you can work on these exceptions. We also saw how to use multiple try blocks inside a try block, nested try blocks, right? And we also saw how to catch multiple exceptions using a single try also. I think this is enough for now. We'll continue this tomorrow. If no one has any other questions, then okay. If someone has any other questions,
Karthik, actually, tomorrow we also discuss about exceptions, or
yes, most probably exceptions only, sir. We have many more topics to cover in that area.
okay. Then I'll ask tomorrow.
Sorry, you will
Then
ask
I'll
tomorrow.
look up some questions for tomorrow.
Okay. Okay. Others. And
Basically, I have some queries related to Selenium related exceptions, so that's why I thought we'll discuss tomorrow.
okay. Fine, Saga. Then I'm wrapping up the session. I didn't post yesterday's